And here's what I'm going to be talking about tonight, basically different Ruby implementations. MRI and YARV, which is what everybody knows as Ruby, Ruby Enterprise Edition, JRuby, Rubinius, and MacRuby. And if we have time, I'll go over some benchmarks that kind of show the differences, the, I guess, benefits of each of these. So let's get to it. So MRI is the one that basically when people say Ruby or you install Ruby on your system, that's what you're talking about. It's also called YARV, which is, MRI was Ruby 1.8, and then YARV was yet another Ruby VM, and that was 1.9, but people just call it MRI mostly. And it's pretty much the standard for what Ruby's supposed to do, and it'll be compatible with more or less any gem or library. I've never really seen one that is not bundled with another Ruby that doesn't work. And it's really well tested, even on the less common platforms. Like had some issues with Solaris running JRuby or Rubinius, but not MRI. It should be fine. Its performance is not very good, and that's compared to the other Rubies. And it also has the problem of using a GIL, which is a global interpreter lock. So if you do threads on MRI, basically, instead of running things parallel, it goes back and forth really fast between all the different things it's supposed to be doing. It usually only uses one core if you have a multiple core CPU, or one CPU if you have multiple CPUs in a box. And that's one of the big drawbacks of using it for anything that's like a daemon or a background process, as opposed to like a web app, which usually has multiple instances running at the same time.
Now they made an improvement on that in 1.9, didn't they?
The improvement is GIL. There's something called green threads, which is basically just fake threads in 1.8, which is actually worse than the GIL. It's not very efficient at all. In 1.9, they moved to the GIL, which basically allows you to treat threads like they're threads, but it won't utilize all of your cores, all your processing power. And if you only have one processor, that's not really a big deal. But a lot of times, if you're running like a server, you're going to have 16 cores, 32 cores. You're really going to use one of them in 1.9. That's per Ruby process. So like if you're running Unicorn and you spin up 10 processes, you might be running 10 at once because the OS is doing the threading, not Ruby itself. So a lot of this is going to apply more to running like a daemon or something, or something you might do with like a messaging service rather than an actual live like web process in Rails. And most people are pretty familiar with this. There's not that much new information to talk about here. Alright, so Ruby Enterprise Edition is basically a fork of Ruby 1.8. It's not compatible with Ruby 1.9 stuff, and almost the entire reason for this existence is a copy on write, which is really important if you want to do like pre-forking on a web server. Does everybody know what that is? Or okay, so like if you're running Apache, or it's usually Apache, but other web servers will do this. They'll basically spin up processes, not really like a new PID, but a process that has access to all the memory. So if I have something that defines a whole bunch of objects, and I want to serve this request really quick when a client connects to me, I have all this stuff ready to go. It's called pre-fork, which is basically because it calls fork, and then when a client connects to me, I'm like, here you go, all the memory's set up, and it's ready to go. MRI, the way it does garbage collection, does a mark and sweep. So every time it marks, goes through, it's going to say, okay, look at every single object in memory. If it's in use, mark it. If it's not, leave it blank. And then the sweep goes through and throws out anything that's not marked. This is a big problem if you actually want to do pre-forking, because if you basically fork and copy everything to the child process, it's not really in use. So it kind of prevents that from happening. So a lot of people will use something like Unicorn or a Mongrel and Thin used to be popular ways to do this, to spin up actual live Ruby processes instead of actually just doing pre-forking. Ruby Enterprise Edition basically fixes that and adds tweakable garbage collection, which is, they just redid the whole garbage collection stack. Other than that, it's going to work just like Ruby 1.8, and it's actually pretty compatible with most gems you would use for 1.8. But 1.9 did some improvements to garbage collection where basically they're not using this anymore. They have a Fusion Passenger, which is like mod Rails. They still distribute that, and that kind of gets you close to what this would do in 1.9. So it's not really necessary, and this doesn't add a whole lot as far as like actually writing Ruby code. This one's really more for like improving your server. You can get like a third better memory performance just by swapping this out, and it should be pretty much completely compatible. So if you have an old like Rails or a Ruby 1.8 app and you just want it to run faster, this would be a drop-in replacement. You put this on your server along with Apache and then pre-forking works, no more problems. And that's pretty much what I was just saying. The copy on write allows it to do pre-forking, but that wasn't really necessary for 1.9, so it's going away. I wouldn't really write any new software for this because hopefully you're writing your stuff for 1.9 now, and this isn't going to go to 1.9. Alright, so Rubinius is basically a project that exists. They wanted to write as much of Ruby as possible in Ruby itself. So there's still like a core VM that's written in C that runs, but a lot of the libraries that are written in C extensions have been rewritten as Ruby. And it's also just an attempt to clean up the code base. So for the most part, it runs a little bit faster than the same thing would run on MRI or YARV. And it's also really good for trying to understand how Ruby works, at least if you're not really comfortable reading the C code that makes up the actual proper Ruby. These files are really well written and clean. And they redid garbage collection in this as well, which is really efficient if you're running long-running processes. And I think, I didn't write it on here. The other biggest advantage of running Rubinius is it's going to sort of pre-compile your code. So if you run something in Rubinius, like if you have a Ruby app and then you like RVM switch to Rubinius and you run it, it's going to create a folder that's called .rbx. Inside there you're going to have some bytecode, and so it does this on its own. You would just run the application, and then the next time it runs, on any subsequent run, it's going to see that exists and just run it. And that actually speeds it up pretty good for applications that will run the same code over and over within the lifespan of the process. It's not bytecode in the way that like we're going to talk about JRuby and MacRuby here in a minute. They'll do the same thing, but they're actually like binary files that will run on like the JVM. This is going to be like an ASCII text file that's, looks like a big ugly mess of letters and stuff, but it's more efficient to run rather than actually parsing everything at runtime, and it doesn't create any problems with some of the weird stuff you can do for Ruby. We'll talk about JRuby in a minute, but throwing that stuff into Java bytecode can cause some problems with meta-programming techniques. They'll all be supported, but it won't be as efficient. And this is going to get around that by the way it handles the bytecode. It's also doesn't have great library compatibility just because pretty much any C extension gem that you would want to install is not really going to work right on here. That's just the way it is. You can't really compile things for Rubinius. And the other big drawback is right now it only supports 1.8 compatibility, but they're working on 1.9 compatibility for this.
So is Rubinius, does it check for changes like in the original source files? So can you like change the source file while it's running and have to pick that up?
Not while it's running, no, but like if you were to run it and then you were to run it again, it would notice changes, but if you changed it while it was running, it's pretty much going to compile it up front, create the files, and then run off that file, and then if you run it again, it would pick up the changes and get it going for you. And then kind of my summary for this was it's a little bit less mature than some of the other Ruby implementations. They have a bunch of goals that they're working towards but haven't met yet, like getting rid of the GIL for native threading and 1.9 compatibility, but what is implemented tends to get pretty good performance compared to running MRI or something like that. Generally, people don't usually write code against Rubinius, like intending to use it that way, but it's sometimes fun to test out an application, and if it works better, you might run it that way. We run a Chef at Opscode is all written in Ruby, the client side, and I got about a 25% performance increase by running against Rubinius, and didn't have to change any code to get it to run. That being said, I think what we do and what most people do is we don't really test against Rubinius. If it works, that's awesome. If it doesn't, then don't use it. And I think most people are kind of treating it that way right now just because it's not as reliable a target. It's still moving a lot more. They have goals they're trying to fix, but aren't there yet, so the threading could change at any moment. But what they've done is pretty cool.
You said library compatibility, so is that like not all gems work with Rubinius?
Yeah, most of the ones that are like native C extensions will have issues. Some of them work, but for the most part, they won't really compile and run properly, at least in my experience. But that's not a hard, fast rule. That was just kind of what my testing showed.
And so nobody really runs this in production.
I know Engine Yard uses some stuff in production that's built on Rubinius. They're the sponsor of it. Outside of them and the people who are actually writing it, I've not heard of it running in production, but I've heard of it offered as like, test your app against Rubinius, and if it works, run it against it. So I think a lot of people will do that, like at Engine Yard. They're like, let's try it on Rubinius, and then it works, and they're like, oh, that's good. But you know, from all the research I did, there's not a lot of people outside the people writing Rubinius that are actually doing production stuff against it. It's not common. The next two I'm going to talk about, like JRuby is another sponsored project. That's pretty common for people to like run in production and actually write against, because it's going to add some stuff that's not in MRI. Whereas the extra stuff in Rubinius changes a lot. So I've not seen really any apps that like recommend, hey, run this on top of Rubinius, unless they're written by Engine Yard and the people who are writing Rubinius. That's not a knock against Rubinius, because it's newer than the other ones, and it's, you know, still a moving target, like I said. So I think one day it'll get there, but where it is right now, you don't see a lot of people using it in production. Okay, MacRuby. This is another one of the ones that's actually it's been around for a while, and it's pretty mature. It's Ruby, but it's using all the OS X technologies, the Objective-C framework, LLVM compiler. It gets really good performance if you're running it on a Mac. And it's got Hot Cocoa is basically a library to make native Cocoa apps in Ruby. My understanding is you can put apps like in the new Mac store on this, and some people use it for that. I don't know what is actually written on there. But it also supports a lot of like the scripting framework for OS X. People that might use like AppleScript or something, you can tap into all that through MacRuby and do like your OS X scripting in Ruby, and then everything tends to work pretty well. So it's pretty common for that right now. And I believe there's Ruby Motion. Is that what you said it's called? It's written by the same guy. It's not actually the same thing, but Ruby Motion is like a way to run Ruby apps on iOS. I actually didn't play with that when I was doing this, so I don't know a lot about it, but I know it shares a lot of the code, but it's not identical to this.
You write Ruby-esque code, and it compiles it using the LLVM compiler to Objective-C.
Okay. So, I guess, so it's not actually Ruby, like it wouldn't follow all the same, like syntax and everything?
So it looks like Ruby. There are some things which you're not allowed to do, mostly around meta-programming or any kind of dynamic programming, so requiring files, for example, requiring gems, anything to do with kernel, that kind of stuff is blocked out.
At runtime.
At compile time.
Oh, wow.
At compile time. And I'm not sure about whether or not how closely it's tied to MacRuby. I'm fairly certain it is.
It sounds from what you're saying, I haven't played with it, but it doesn't sound like it's, I know it's written by the same person, but
Yes.
it doesn't sound like there's a lot in common, because in MacRuby, you can do whatever kind of bizarre Ruby stuff you might want to do. All the dynamic programming you want will work, even if it's compiled, which MacRuby comes with MacRuby C. It will compile your Ruby program into basically a binary you can run on OS X. And there's not really restrictions of what you can do. It supports 1.9 compatibility. I think only. I don't think you can do 1.8 stuff or exclusive stuff in here. And it's pretty much,
I think the
feature-wise, on par with what MRI can do.
And the purpose is slightly different too. So MacRuby, not all MacRuby apps will run or can be shipped on the App Store. But the idea is to have all Ruby Motion apps be produced and shippable on the App Store. So you're not going to get any sort of, nobody's going to tell you that you can't write this app because it does something. So the idea is to make it entirely compatible with the App Store and the App Store's policies.
Yeah, so MacRuby's actually been around longer than there was an App Store, and it was kind of initially just let's throw a native Ruby in for OS X, and I don't think they've removed any functionality, so regardless of what Apple says you can or can't do, as far as code running, you could do whatever you want to do with Ruby in MacRuby. I don't know the rules for the App Store because I've never had to deal with that, but this isn't really restricted the way Ruby Motion would be. It does have some issues with library compatibility. It's mostly pretty good. Most of the stuff you can run on there, but it's not going to compete with just running MRI. You can't just assume any gem is going to work. And since this does allow you to just basically just tap into all the frameworks that are built into OS X, a lot of times when people write this, they're writing code just for MacRuby that's not going to run on another version. So it has some of its own gems that are made just for that. And then there's libraries like Hot Cocoa. Like, you can't take that and then port it back to MRI. Once you write it on MacRuby, it's done. And its single biggest drawback is it only runs on OS X. Its performance is great. It's really stable. But if you write something that uses specific like MacRuby code, you can't move it. And assuming we have time to get to all the benchmarks and stuff, it has its own way of doing threads that are different from the threads that are built in, which is really, really efficient. It's the fastest way to do parallel processing I've seen in Ruby. And it actually adds its own library on there. So it's not like JRuby, when it gives you native threads, you use the threads library from Ruby, so the code looks the same. That's not the case in MacRuby. Alright, so JRuby is probably the most popular of all the alternatives, and it's Ruby implemented on top of the JVM. Its biggest advantages are basically cross-platform performance and stability. The JVM runs basically everywhere, and it's really fast and really stable. And this is just going to put a Ruby interpreter on top of the JVM. It gives you native multi-threading again because the JVM does that, and you don't have to change your code to get native multi-threading in JRuby. So if you have a Ruby app that uses threads and its performance is bad, you can just run that code against JRuby, and then you get a great performance benefit. It also has much better memory management than MRI. Probably not better than MacRuby. I didn't do a lot of high memory usage tests against there, but it'll give you your memory back when you're done with it, and it won't use as much. That is, it doesn't use market sweep like I was talking about for Ruby Enterprise. Its library compatibility is pretty good, but not as good as MRI. And then I have a typo on here, but metaprogramming can hurt a lot if you're compiling code. And the reason for this is basically when you compile code with JRuby, it's going to make a bunch of Java class files in there, and it knows where the Java class files go by defining classes. So I'd be like, class this, and then it makes a file for that. If you're doing weird metaprogramming stuff where you're not explicitly defining classes, but you're throwing them in there at runtime, everything just gets tossed in a generic class file that has all the functions. And this should go the same thing if you're putting define method in there or doing some stuff with method missing. You could do it, it'll still run, but you'll take a big performance hit if you're actually compiling and distributing your code. And the other thing this can do that other languages can't is you can invoke native Java classes, and you can call JRuby from within inside Java code. It's pretty popular to use for people that have big, old enterprise Java apps, and they want another language that they can write faster to basically augment it, but they don't want to run everything in Ruby because it's kind of slow. You might use JRuby to basically pull something in from that class, use it, and then do some processing in Ruby. Its performance is good, but not as good if you write Java code and then compile it and run it, which is why most times when you see people doing that, it's mixed the core logic of being Java, and then they'll just tap into it with JRuby. You can do the inverse, which is basically inside JRuby, write some Java code and then have it kind of compile it on the fly. I don't really know why you would do that since you can already invoke Java classes, but I know that you can. And summary here is basically performance and stability, make it a good fit for anything that needs high performance. And when I say high performance, a lot of times this is not really into web apps where your bottleneck is going to be a database or something. This is I have a long running process on the back end or a service or something, and it needs to be really fast. JRuby should be faster, and it'll let you tap in actually using Java if you need it to be really, really fast.
So I think this is your secret weapon if you're stuck in a Java shop and you want to do Ruby, right?
And they'll allow Ruby code in their code base.
Is it faster to use JRuby and then drop down to Java to write something fast as opposed to use Ruby and then drop down to C to write something fast?
I would assume so, but a lot of it's going to depend on context. Native compiled C code, if it's written really well, stands that it could be faster than compiled Java code, but you could write really bad code in any language, and you can write really good code in any language. So I would say stick with what you know.
I certainly think the integration with Java is a lot easier than the integration with writing like something in C.
I think what he's mentioning, we were talking a little bit before it starts, but in Ruby there's a library that I can't remember its name, but it lets you throw C code in line in your Ruby script,
Yeah, it's by
compile it on
ZenSpider.
the fly, and then just run it.
Yeah.
And it gets really fast if you have something in Ruby that you're like, oh, just this little part is a huge performance problem. And as opposed to doing that in JRuby with Java, where you could do the same thing to have compile Java on the fly. And the big difference is you get a little bit more control over memory and that kind of stuff when you're doing like JRuby and Java than you do just writing JRuby code. So if you had like an algorithm that was just killing you as far as memory usage or something, you could drop into Java, just handle it there, and then go back to JRuby. I don't know if a lot of people actually do that compared to like wanting to use Ruby with a Java application. I think is a lot more common for use, but you could do it both ways.
The threading in Java is like really mature too, so there's like a lot of cool stuff you can do with optimization there. That's like, I don't know, it seems like Ruby is like a little bit younger in that way.
Yeah.
Yeah, I think actually as far as using JRuby and not using it along with Java, threading is the single biggest pull to actually switch over to JRuby because you do get native threads on top of the JVM. So even without having to use the code, which there is extra libraries included with JRuby that aren't in like MRI, but even without doing that, the performance for threads is just way better in JRuby compared to just regular Ruby. And I'm going to try to go through this stuff fast just so I can show some of the benchmarks that kind of show that. This is just kind of a chart for when to use it. I'm not going to talk about this. If you want to look at it, go to pmoring.roku.com and all these slides are up there. You can read through that if you want. But these are a couple benchmarks, really simple stuff that just kind of show what one can do that the other can't. This one's basically just does some recursive stuff. Factorials iteratively and recursively. And I'll show you them all now and then we'll run them in a second. This basically does a whole bunch of mathematical stuff a whole bunch of times just to see how fast you can process numbers. Just multiplication to do a baseline and then square root, cosine, and a logarithm. And then this is the thread stuff. So I have two benchmarks here for threads. This one is basically going to connect to a bunch of sites using threads and not using threads to look at the difference in speed. And I call this one simple because the real difference here is the threads aren't actually doing stuff. You don't really need any like CPU time to connect to a website. You're mostly waiting on the website to return something to you. So the benefit you get out of threads is actually not having to wait on the first one to return. And in this case, the GIL that we were talking about for MRI isn't really too much of a problem because it allows you to do one, and switch to the other, do that, and send all the requests, and then get them all back. And you're not really waiting on processing. As opposed to this one, which is just doing some of the same math stuff, but it's doing it with threads. And in this case, you actually want to do something with your CPU while you're doing the threads, which is where the parallel processing comes in, because you can use all your cores using like JRuby or MacRuby, and you can't do that using just regular Ruby or Rubinius. So, let's see. So right now I'm just on Ruby 1.9, and I'm going to go ahead and run the recursion one first. Most of these should be pretty fast. And by the way, this is going to run all the benchmarks twice. You partially do that just to make sure there's no garbage collection magic that makes one look faster than the other. But it's also a little bit important when you're testing Rubinius because the first go-round is going to compile the code, and then the second go-round is going to use it pre-compiled so you get a better feel of how it would run like in production. So there's not a huge difference here because it's something complicated, but you can see when you're running regular Ruby, recursion is almost always slower than an iterative process just because of the way it handles it. And you hit a max depth pretty quick when you're doing that. which you won't enter the rubies. So switch over to JRuby.
You can run JRuby 1.9 or 1.8 mode too.
Yeah, you can. I think it's 1.9 by default, and I don't usually run it in 1.8 mode. I don't usually run anything in 1.8 mode though, but I think MacRuby and JRuby both will let you try to emulate 1.8 compatibility. So you see the same thing basically in JRuby, but I think what we should find out here in just a second is the second benchmark is probably going to be a little bit faster because there's some overhead with starting up the JVM that you don't necessarily, well, you have some overhead in MRI, but it's not as bad. You don't take as big of a hit. And I don't know if this is going to be, it's a little bit better, but it's not really that significant. But what's important here is JRuby at something trivial like this, just because of a lot of the overhead, is actually slower than just running regular Ruby, like we did before. This is one of the reasons why a lot of time for like a Rails app, even though JRuby supports Rails, people don't want to use it. If you have really simple processes, it's like, hey, connect to a database, give me something back, and then display it. You don't really get a benefit from JRuby. You shouldn't take much of a hit, but you might take a little bit of hit just because there's some overhead. This is assuming we're not doing any calculations here. So I'm going to switch over to the one that's processing now, and then things will be a little bit different. Actually, I'm going to do MacRuby first just to show some of the overhead with that. And this is a lot of the same thing. There's a little bit more overhead just starting it up, but the MacRuby is also not terribly efficient with doing recursive algorithms, which is part of what this is showing. I mean, 10 seconds to 16 seconds isn't that big of a difference, but if this was a full-featured app that was doing this a million times, it would be a lot different. Probably should have run these a little bit less times in my benchmark too. This isn't that interesting, so we'll skip it. Alright, so this is the one that just runs a bunch of mathematical functions. We're going to do like some multiplication just to kind of establish how fast it's doing things, and then it'll go and do like sine and a square root and something else. There we go. Most of those are in like the 2.5-ish range. Now, compare that to JRuby. Excuse me. And the reason I want to show you this basically is because after I do this, I'm going to run all the threading applications, and you'll be able to see basically the difference in running threads versus just running this. So obviously JRuby is quite a bit faster at doing all the mathematical calculations than just MRI was. Most of those are in the less than a second range compared to the 2.5 we saw in MRI. You'd see the same thing in MacRuby, but I don't feel like running all of them right now because these are not as interesting as the threads. Okay, so I have the three benchmarks I have here are the threads, which is just a simple one that connects to a bunch of them, threads in math, and then the MacRuby threads in math, which is the one that uses the extra library that MacRuby does. But we'll get to that in a second. So this is just using regular Ruby.
How many iterations is that one doing?
This one's just doing one. This is the one that tries to connect to a whole mess of websites,
Oh,
and I
that's
think
right.
it's connecting to 8 or something like that.
Okay, good.
And the reason this is interesting is because you can see we got not quite 4 times better performance, but more than 3, in spite of the fact that this has the GIL on there, and that's because there's no processing power. The threads allow me to just say connect to this one, and then we'll get back to the first one later. So in this one that took 4 seconds, the reason it did that is because I'm mostly waiting on somebody else's server rather than my own computer to run stuff really fast. Whereas if I run the one that uses a lot of processing power, then we're not going to see those kind of gains, because even though I'm switching threads, most of them are still waiting on the CPU. So when I switch to one, the other one has to stop running. So you can see there the threads actually ran slower. I don't know, maybe 50% slower, somewhere in that range, and that's because we're stopping the process to go to another one. So there's more overhead in there, but I'm CPU pegged, so I'm not gaining any advantage at all by using threads. That's not the case with using like MacRuby or JRuby, because they have native threads, and that's the big reason people want to use them. So let's switch over to JRuby. And you're going to see not much better performance comparatively to threads versus non-threads than we saw on just regular MRI here, because most of my time is spent just waiting on the remote servers to respond to me. I'm not really spending that much time doing any kind of processing. It's still faster, but it was about the same in MRI. So the interesting one here is the one that uses the processing power. So this is why people really want to use JRuby for performance here. We got a huge gain in performance by using threads versus not using threads, where we took a performance hit when we used threads on MRI. So basically, I'm using, I think this is a 4-core laptop here. So I'm using all 4 cores to do processing. I'm doing it efficiently, not sending a bunch of interrupts to switch back and forth. Whereas MRI is basically just interrupting and pegging 1 core. So that's the biggest performance benefit. Obviously, the processing is just faster in JRuby, but there's a huge performance benefit by using threads. And MacRuby can kind of do the same thing. If you use code that's the same as the other code in MacRuby, you actually take a hit because it still has the GIL, but it has its own way to do threads. Oh, you know what? One more thing about MacRuby is it has MacRuby C sent with it. That's the compiler. I could give it a Ruby script and then a -O for an out, and you get a binary. You get better performance out of that, but it's nothing earth-shattering. And if I don't put the C on there to compile it, then I'm not actually compiling code, which is not the case with Rubinius. So I'm going to skip the regular threads. It's going to show us the same thing as some of the other two. But this performance, in my experience, is really, really awful with MacRuby. Like, I was getting 10 times worse than MRI when I was running it before. I don't really know why that was happening, but it was pretty consistent. So hopefully this won't take too long. All right, well, this runs. Does anybody have any questions about the threading stuff?
This one here is not using the MacRuby.
Yes, so this is the exact same code we just ran on JRuby and on MRI, and you see there when I run with threads on, that's horrible. That's awful performance, and it's pretty consistently like that. I think that's because I'm doing processor-intensive stuff. I did not see that when I ran the simple threads that aren't waiting on CPU. But MacRuby has a different way to do threads with its own library that I'll show in just a second here that actually gets pretty impressive performance. The point being, MacRuby isn't a great drop-in replacement to just say, let's make this code faster, but if you develop it to be a MacRuby application, you actually get pretty good performance. And I'm going to skip this because I don't want to wait for that. We get the point. Now. So this is the threads, this is the code we were just looking at under the other ones. And this is basically using the MacRuby dispatcher, the way it tries to do threads, the Grand Central Dispatch. So, I should have made this slower on this one too, because now I have to wait another 30 seconds for it to do that. There we go. So that's pretty good performance gains there. You can see 0.005 seconds is a lot better than what we got, even running no threads, but even in the threads from JRuby. The performance is just really fast using the way MacRuby wants you to do it. And that's consistent against all the other thread tests I have there. Same with like the simple ones, but I didn't bother to write them out for everything because it takes forever to run the example. And then the last thing I wanted to show was,
0.005 versus 2 or 3 seconds?
oh, 2 or 3 seconds was the MRI, yeah. It's here for the regular threads versus the Grand Central Dispatch. It's 0.005 versus 36 seconds, which is faster.
I wonder if this would be even faster with like Event Machine or something, where you're introducing some asynchronous into the threading. I'm just curious.
As far as what, well, the thing is, like,
You're still waiting on the sites to come back. I mean, those sites
this isn't the one that waits on the sites.
Yeah.
This is the one that just throws a whole bunch of calculations in there and says,
Oh yes, that's probably pretty close.
yeah, so the sites ones, like, basically, the whole point of that is just to show that threads serve a purpose when you're running Ruby, but it's not parallel processing.
Right.
This gets you better parallel processing capabilities, and that's why it exists. But since the syntax is different, it has its own libraries, it's not really a drop-in replacement. So this is Rubinius, and the point's not the benchmark. I'm actually not even going to run it. But what I wanted to point out is once I run anything with Rubinius, on the fly it creates this .rbx directory, which actually put the code in there. And that's what it generates, which doesn't look like a lot of stuff to us, but that's basically the compiled Rubinius. And now if I was to run it again and not change the code.
Is that the whole file, or can you? Is that the whole file? No.
Oh, no, it goes up. I just ran a cat. It looks like this if you read the whole file, though. It's not particularly interesting. And that's it. Any questions?